Okay, so the final lesson in this unit is going to be all about the constant acceleration formula. So they're the kinematic formula, the Suvat formula that we did in Unit 9 of mechanics. And what we're going to do is we're going to look at how this idea of being able to differentiate or integrate ties them together. So let's just recap a couple of things first. So we know that displacement, velocity, and acceleration have this relationship where if we want to move down, we're going to differentiate, and if we want to go up, we're going to integrate. And what we're going to do is we're going to see how those formulas, the Suvat formulas, tie in with what we've been doing. So it sets up this question here. It says there's got constant acceleration A, initial velocity U, and initial displacement 0 meters, and it asks us about the velocity and then the displacement. So we're going to start off just by writing down that the velocity is equal to the integral of the acceleration, right? That's what we've been doing the whole time. If we've got acceleration, we want to get back to velocity, and our variable is always t, so it's d with respect to t. So if we then integrate this a term, right, a is just a constant in this case because the integration is with respect to t, we'll end up with at plus c, where that's the constant. Right, and you can see straight away this looks very similar to our v equals u plus at equation, but we've got a c rather than the u. So what we're going to do is we're going to use this idea. Its initial velocity is u meters per second. So we know that if it's initial velocity, that's when t is equal to 0, we have that our velocity, which is v, is now equal to u. So we substitute that in, and we have that v goes to u is a times 0 plus c, so that gives us that u is equal to c. Right, and then we replace that, and we get that v equals at plus u in our original formula, and if we rearrange that, we get the result that they are looking for. Okay, so that's how we move from just having the acceleration to having that velocity equals u plus at, using that condition that for the initial velocity we've got that t is 0 and v will be the same as u. For part B, we're going to take our result for part A and we're going to integrate again, right? We had acceleration to start, we got to velocity, and to get from velocity to displacement we have to integrate this. So we're just going to take our v and we're going to integrate it. So we're going to get s, which is the displacement, is the integral of u plus at dt. So this becomes ut plus at squared divided by 2 plus c, which again is ut plus a half at squared plus c, which is exactly what we want, except we've got a c on the end, right? So displacement at time t is given by s equals ut plus half at squared, but I've got this pesky plus c. So we go back to the question and we see there's some further information that tells us that the initial displacement is 0. So that tells us that s is 0 when t equals 0. So if we substitute that in, we have that 0 is equal to u times 0 plus a half times a times 0 squared plus c. You'll get that 0 is equal to c, and then we get our result that we want. So s is ut plus a half at squared. Okay, so that's where the displacement, velocity, acceleration, the Suvat formulas fit in with this idea that we can differentiate and integrate. So we can still use that idea to integrate to move between v equals u plus at and s equals ut plus half at squared. So the next exercise that you're going to do is going to be very similar to all the exercises we've done in this unit so far. It's just using this idea, but it's going to be a bit more algebra in. So it's not necessarily going to be numbers. We might be playing with these formulas and moving between them with differentiation and integration. The key is to remember that it's always t that we're differentiating or integrating with respect to. So that's always the variable, right? Time is always going to be the variable that's changing. So when we integrate, it's with respect to t. So we treat the t as the thing that will change, and any other letter is treated as a constant in the integration or differentiation. So have a little go. It's going to be exercise 11E, question 2 to 6.